Good day everyone. So today's video, I'm gonna discuss about describe rotational quantities using vectors. What is rotational quantities using vectors? Rotational movement is described using vectors by defining an angular velocity vector, where the vector's direction indicates the axis of rotation and its magnitude represents the rate of rotation, determined by the right-hand rule. In 2D, rotations of a specific vectors are handled through the rotation matrices or operations like the cross product to find a new vector that has changed direction but the same magnitude. So imagine something spinning like a wheel. To describe how it's spinning, we use something called a vector. So this vector is like an arrow that tells us the two important things, the direction and magnitude. We call this special arrow the angular velocity vector because it's represented by the symbol omega. So in simple terms, vectors help us describe rotational movement by telling us which way something is spinning and how fast. Angular displacement. Angular displacement refers to the angle through which an object rotates, measured in radians. Its vector's direction is determined by the right-hand rule, pointing along the axis of rotation and indicating the direction of the turn. So in simple word, angular displacement is how much something has rotated. So here's an example. Imagine a DVD spinning. If it makes one full rotation, its angular displacement is 2 pi radians or 360 degrees because the right-hand rule tells you the direction of that rotation axis. Angular velocity. Angular velocity is the rate of change of angular displacement calculated as omega is equal to cos over time and is measured in radians per second. The vector direction of angular velocity is along the axis of rotation as determined by the right-hand rule indicating how quickly the object is turning. So, angular velocity is how fast something spins. It is the rate at which an object rotates, and if we're gonna find the direction, we're gonna use the right-hand rule. And in short, it tells you how quickly something is turning. Angular acceleration is the rate of change of angular velocity calculated as alpha equals change in omega over change in time and is measured in radians per second squared. Its vector direction is along the axis of rotation, either in the same direction as angular velocity if speeding up or opposite if slowing down. So here's an example. So if its angular velocity changes from 2 rad per second to 6 rad per second in 2 seconds, the angular acceleration is. So A or alpha is equals to 6 rad per second minus 2 rad per second over 2 seconds is equal to 2 rad per second squared. This means the top's rotation speed increases by 2 radians per second every second. Torque. Torque is a twisting force that causes rotation, defined as T is equals to R times F, the cross product of the radius and force vectors. The vector direction of torque is perpendicular to both R and F, following the right-hand rule and indicates the direction of the rotational force. So torque is a force that causes something to rotate. So here is an example. Imagine using a wrench to tighten a bolt. If the wrench is 0.3 meters long, R is equal to 0.3 meters, and you apply a force of 50 newtons, or the F is equal to 50 newtons, and the 10 of the wrench, the torque is T is equals to 0.3 meters times 50 newton is equals to 15 new meter. Angular momentum. Angular momentum measures an object resistant to changes in rotation, defined as L is equals R times P or L is equal I omega. The vector direction is along the axis of rotation determined by the right-hand rule. So for example, imagine a spinning figure skater. If the skater extends their arms, their angular momentum stays the same, but the rotation slows down. If they pull their arms in, they spin faster because the radius decreases. So, if a skater with mass 50 kg is spinning with arms extended 1 meter for their body, and their velocity is 2 meter per second, then L is equals to, so here they are. 1 meter times 50 kilogram times 2 meter per second is equals to 100 kilogram times meter per second. So here we are in conclusion. Vectors are essential for describing rotational quantities including angular displacement, velocity, acceleration, torque, and momentum. Understanding vector operations is crucial in analyzing rotational motion in numerous scientific and engineering contexts. And that's all. Thanks for watching!